Can you hear me? Audible? Dr. Luca, can you hear me? Oh,
Yes, hello, good afternoon.
good
Can you hear
afternoon,
me?
Dr. Luca.
Thank
Yeah,
you.
I can hear you. Well,
Good.
sorry for the delay, and let me just introduce you for a moment.
Okay, no worries.
Well, it is my immense pleasure to introduce you to all our students and faculty members. Well, I will increase my volume because other participants need to hear it. Uh, so Dr. Luca joined us here now in online mode. Let me introduce him, okay, for a moment. Dr. Piras is a distinguished researcher specializing in cybersecurity, privacy engineering, secure software development, and requirements engineering. He is associated with Fondazione Bruno Kessler, FBK, a, a prominent research center in Italy, and has collaborated with several leading European research institutions. His work focuses on developing secure, privacy preserving, and trustworthy digital systems that address today's cybersecurity challenges. We are really honored that he has joined us virtually despite the geographical distance. Thank you for taking the time to be with us today. We are honored, really. And please join me in giving a virtual round of applause, everyone, as we welcome Dr. Luca Piras. Can you give a round of applause? Sir, can you start your session? We are waiting for you to start.
Yeah, thank you very much for your very kind introduction. Can you hear and see the slide? So can you hear me and see the slides, right?
Yeah, I can see you. Sorry, there is a
Okay.
power.
Okay, thank you very much. Okay, so hello everyone. It's my pleasure to be here and thank you very much for attending my keynote. So I would like to start with thanking Professor Bhattacharya that invited me to this prestigious conference and to give this keynote to you. So it's my honor and my pleasure to do that. Thank you very much, Professor Bhattacharya. And just to give you just some information about me in practice and has been the research journey that brought me to give this keynote today. In practice, I worked in different European projects. These were related to important topics such as software engineering, requirements engineering, privacy engineering, and artificial intelligence. And I had the possibility to serve in different European universities. And in any case, my main background is related to software engineering, and in the years it shifted towards AI for secure software engineering and software regulatory compliance. That is the main topic behind this keynote. So just showing you my last movement, let's say from the UK to Italy. So I was in my last, a little bit more than 1 year ago, I was in Middlesex University, London, in the UK. I was a senior lecturer and a BSc IT program leader. And there I had the possibility to do research, but I had also the possibility to teach full stack development, software engineering, secure software engineering, and other related topics, with also administrative activities, as you can imagine. And then I moved to FPK, my current institution in Italy, that is Fondazione Bruno Kessler, that is a research center that in practice is internationally renewed, and we have a lot of projects, and there are brilliant researchers that works within our center. So as you can see, of course, a big move, because a very different landscape. One was in the cosmopolitan metropole of London, that is amazing, and now I am in Trento, that is a smaller city near Dolomites, and the landscape is with mountains, etc. In any case, both very good experiences. And in terms of research, as I mentioned you, during all these experiences, I moved from software engineering to AI for secure software engineering and software regulatory compliance. And here in FBK, I am a member of the Center for Cybersecurity, and I had the possibility to create the SafeWare Research Unit, that stands for Secure Code Lifecycle for Applications and Networking. So as you can imagine from the acronym, SafeWare Unit is related to secure software systems and also networks. In any case, as we will discuss today in this keynote, our vision, our research vision is broader than that. And so I am happy to introduce it. So in practice, first of all, before to enter into the details, we need to consider what is the current landscape, because as you know, we are entering in a new era, the era related to artificial intelligence, LLMs, VLMs, and so everything is changing, and there are many aspects to consider. Also, organizations are changing their ways of operating. Software engineers need to adapt to a number of new activities and technologies. And so if we consider, first of all, these aspects, we have, of course, that since 2022, as you know, LLMs have been introduced and created a big shift in our lives in terms of working, but also from a societal perspective. And now we are going towards having agentic infrastructure. So infrastructure where agents autonomously carry on activities on our behalf, and in practice, sometimes what they do is not 100% clear to us, because it's of course a new technology. And so increasingly we need to understand how humans can collaborate with artificial intelligence. And so the human in the loop aspect is fundamental in this entering in this new era, as you can understand, because we need to supervise, to understand, to control, to understand exactly what these agents can do. It is a very positive thing, but we need to manage it in a proper way. And so for this reason, we need, of course, to find new secure software engineering ways to manage all of that. In parallel to this, other technologies are speeding up a lot, such as cloud computing, the advent of quantum computing that is becoming closer and closer, and we need to consider all of that in relation to what I was discussing. So the landscape is very complicated, and what is further complicating it, of course, it is a positive thing on one hand, on the one hand, because of course we need also to regulate AI, LLMs, and what is happening. But in any case, what is happening as well, above all in Europe, as you know, there is the introduction of many new regulations. So everything starts with the GDPR, NIS2, DORA and CRA, and so we are having a lot of new regulation that organizations need to comply with. And so if you consider all of these aspects, of course, you can understand that entering in this new era, we need to rethink a lot of processes in terms of software engineering and also in relation to other aspects. So in terms of our vision, what we are doing is in practice to, of course, to consider the foundations about secure software development. So we have, of course, well-established secure technologies that and practices that we need to consider and to evolve in this new landscape. So for sure, we need to understand how to have a secure AI-focused software engineering that I call SAFE, that is related to how to integrate, first of all, AI within our software engineering practices and also the other new technologies. But in any case, this is not enough because what we really need is a complete evolution of the software development lifecycle towards a secure and trustworthy SDLC. So this means that, of course, we need to continue to make sure that the software engineering is secure, reusing and evolving the current approaches, but we need to consider the trustworthy keyword that is something new because these amazing technologies, AI, LLMs, etc., are bringing new challenges. There are many advantages, but there are also new challenges. So, for example, we need to consider the robustness of the systems, the fairness, if there are biases from the introduction of AI models, and we need to reduce, mitigate, identify such biases. And there are many ethical aspects that we need to consider when we are in practice creating software systems. And for this reason, this software and development lifecycle needs to be secure but also trustworthy, meaning that we need to comply with all these principles and overcome these, solve these challenges. In addition to that, of course, as I mentioned, we cannot do this only from a technical point of view, but is a multi-perspective approach. And we need, of course, in this process to integrate in our SDLC a continuous cross-regulatory compliance. So the compliance with multiple regulations, as I mentioned, and in a continuous way monitoring and adapting our solutions in relation to be compliant with the regulation. In parallel to all of that, we need, of course, to consider also the post-quantum transition that is part of this process. And according to that, of course, these parts can help also towards that, but of course, we need to evolve the SDLC also considering the quantum aspects. So this is the big picture, our vision, and so in the next slides we will cover some of these important concepts. And in practice, the goal is how to create this evolution of secure and trustworthy software development lifecycle. So these are the resulting research directions related to trying to develop such a vision. Here I will not enter into all the details because there is not enough time. In any case, what I will do will be to cover the most important parts related to this research, and so I will tell you about the new innovations and what can be done and what we are doing. So if we start with secure AI focused software engineering that I call SAFE, of course, this is something very important. So it's related to the integration of AI within our software engineering practices. And as I mentioned, of course, artificial intelligence and LLMs can bring a lot of advantages, but those have still some important limitations that we need to consider when we try to integrate them. So according to the literature, as you know, if you try to generate a very big complex system by using LLMs, you can get something, but the resulting system is very long, complex, difficult to understand by the software engineers. They are not fully aware of all the components and exactly what each of the components do. and in practice then there could be a lot of bugs and a lot of secure vulnerabilities within a very complex system that is generated by LLM. So for this reason, we cannot directly use LLMs in this way because there are many limitations, as I mentioned. Instead, according to the literature, one thing that is very powerful with these technologies is if you generate a very small snippet of code, a small algorithm, giving precise instructions, etc. So in that case, you can have a good quality algorithm that have less likely these potential issues, bugs, vulnerabilities, etc. So leverage on that, we will propose our framework. And in any case, what we are mentioning is that what we need is to use the best of these technologies, but we need to define on top of them a structured method that can allow the software engineer to keep full control in relation to security, to guarantee transparency, traceability, and to be flexible when using these tools. So according to that, we have defined some research questions. And what we have done so far, it has been also to do some evaluation activities where we compare our framework that I will introduce in some seconds to you. And so we compare our framework, our solution with just using LLMs. And so we want to see what are the advantages and the disadvantages of this approach. So according to the research question, what we want to explore is to understand how we can design a framework that can allow the software engineer to have more control on the generated solution on each part of the system and to reduce the overall development time, because also that is something very important, of course, to keep into account, and to increase the security, as I mentioned, of the generated code in all of its parts. And the other thing that we are interested in is, of course, also to have a good quality generated code and effective solutions that can be used and also maintained in a proper and easy way, let's say. So all of these aspects, of course, are challenging, and what we proposed to keep the human in control and to give control and security back to the software engineer while using these technologies, LLMs, is to build on top of them a visual framework that use visual elements called models in particular that are similar to graphs, let's say, where you can, using our framework, generate your software system starting from the top part, the most abstract component, until going through a hierarchy of layers where you move from abstract components to more concrete components until reaching the small pieces of your system that can be generated as snippets of code. And then when you generate these snippets, our system can merge together all the elements related to that component, and we do that iteratively until going upwards towards the root component that is the most abstract one. In this way, we generate small parts that are validated by the software engineering, can be checked easily, and so we can create a full system that can be more manageable. Everything is based on an agentic infrastructure that in any case I will tell you more details about that in the next slides. Before of that, just some additional details. So I summarized what is our framework, the most important elements. So it is based on generation decomposition of tasks, as I mentioned, of goals actually. And what we do is to use a divide et impera approach based on goal modeling, and we have a top-down method for reaching the generation of small snippets of code, and then a bottom-up method that do the opposite for merging the small components together. In parallel to all of that, we do a number of things, generate the code. We perform also in parallel security checks to support the software engineer. And we are starting also introducing the support for checking the compliance of the code in terms of regulations. So just to give you a very quick example to understand better our method. So what we do is, for example, to design a client application. Sorry for my voice, I have a little bit of sore throat, but I will be able to make the keynote. So in practice, we start from the most abstract concept, so a client application, and we start generating by using an LLM, and in practice it is the framework that use the LLM to specify better what this client application can be designed in components. So for example, then we consider the user interface, and it is still abstract, so we go a layer below, and in practice what we do is to identify the other components that need to be created. And then we go again one layer below for example, for designing anti-phishing UI elements. And so we continue iteratively until we reach the very small concepts, algorithms that can be generated by LLMs, such as these ones. And in practice, then we do the top-down, sorry, the bottom-up approach, where we merge all the sub-elements, and in practice we have a component, and we continue to do that iteratively until reaching the top, the root goal. And so in the end of this process, we have a complete validated by the software engineer system that has been managed with the control of the software engineer. So that's the overall idea, and this is just a very a very quick and simple example. So we evaluated it, our framework within realistic scenarios so far, and we had an incremental approach where we started with having a kind of proof of concept with a single sign-on scenario generated by using our framework involving some students, and we had positive results. So then we extended our pilot study to researchers, more or less 10 researchers, experts in the field. And then we extended it into a controlled experiment in a workshop with 70 participants. And what we did in that workshop was to propose to the participants two different scenarios. And so they had to use our prototype to create a project management software application. And in the second scenario, a web application to manage appointments for a hospital, so in healthcare settings. And so these are the two scenarios, and we divided the participants into groups, into rounds. And in one case, one group used the prototype to generate one scenario, and in the other group, in parallel, used an LLM to do the same task. And then we inverted in practice, sorry, the two groups, and the scenario in the two groups. And so when one group was before doing the one scenario with a prototype, then did just using LLMs, and vice versa. So this was to reduce, to do that in a more rigorous way to reduce potential biases. So what we have understood with this interesting process has been that we have addressed positively our research question that I remind you were related to allowing the software engineer to be in control, to be aware about the software system generated, to reduce the development time, to improve the security and the quality of the generated code. So apart from that, we also understood additional important lessons. And the most important one probably was that the feedback from the participants were related to the fact that we need still to keep the human in control. This is an essential part. So we can, of course, leverage LLMs for our activities, but we need to have structured methods that on top of them can allow the human to generate this solution and keep control over them. Then, and this is exactly what I just summarized, then we understood also that also the validation process, you know, because if you just use LLMs, then you generate a lot of code and it's difficult to validate all the parts. Instead, with our approach, the validation process of the different parts, snippets, etc., and during the merge is facilitated. And another very interesting thing is also that our approach facilitates collaboration because when you create a software system, of course, you have software engineers, technicians, but also project managers, other stakeholders are involved. There could be also lawyers because maybe you need to be compliant with regulations. And so thanks to this approach with visual goal models, it is also easier to all the stakeholders to understand what we are doing, how we are designing our system, etc., and to collaborate. And can facilitate also towards bridging the gap between requirements and the implementation. Of course, we need still to do feature work. There are some limitations on our work. We covered part of what we are aiming. So, for example, we need still to explore aspects such as how to guarantee explainability, traceability, to improve the design of the architecture modeling of our solution, and also to test in real scenarios for long-term industrial studies, collaborating with other partners. So just to conclude this part, in practice, this allows me also to discuss feature work as I already started, but also to discuss about the, the agentic infrastructure that there is behind our framework. So as I mentioned, we need to continue to evaluate and to improve security aspects, usability aspects, and the traceability and explainability aspects. And another important thing that we didn't discuss is also to evaluate the economical feasibility about using this approach that is related to the field of FinOps. This is because, of course, using our approach on top of LLM, as you know, LLMs use a lot of tokens, above all if you work with them with complex systems. And so, of course, we need also to keep a trace about what is the economical impact for an organization in using these novel approaches. And there is the economical part, but also the sustainability part. So as you know, also these solutions, these technology works with a very big and complex infrastructure that consume a lot of energy. So of course, apart from the economical aspect, we need also to consider also the sustainability aspects. And in relation to the infrastructure, the agentic infrastructure we are creating and using for our solution. So we have different agents collaborating each other. We have agents dedicated to some aspects. So one for the generation of goal models, one for the generation of the code, one for checking security aspects. And in the future, we will, in practice, introduce more agents. For example, we are starting introducing also an agent for dedicated to threat modeling to support in this process the software engineer. And we are also starting to consider also more in detail how to introduce a compliance agent that can check also the code for regulatory compliance. And this allows me to introduce the next important topic related to compliance. So, the compliance aspect is a very important point, and what we propose is in practice a guiding compliance framework for cross-regulatory compliance that we call GCFX. So just to go quickly with an introduction, we already discussed partially these aspects. So just to further emphasize on the fact that doing all of these activities, we need increasingly consider the compliance with regulations, and in particular in Europe since 2018, you know, GDPR entered into force, and then there have been a lot of other regulation that entered into force. And the last one that has been proposed is the AUA Act for artificial intelligence systems. So each of these regulations cover a specific aspect. For example, GDPR is dedicated to data privacy, AI Act, of course, to artificial intelligence. And so in any case, for organization, it is becoming super complicated to deal with the compliance with all of these regulations. This is exactly because if you deal with the compliance with one single regulation, it is a complex process. So if you consider, for example, GDPR, it is a very long, complex regulation with many articles. All of these regulations are like that. For example, the AI Act has more than 100 articles. And so dealing with one single regulation with its compliance, it's a very complicated task. But actually what organization need is to comply with multiple regulations. So we are discussing about cross-regulatory compliance, and it is even a more complex process because these regulations have sometimes different overlaps, conflicts between requirements, some complementarities that you need to consider, and of course you need to have in place a system for making prioritization of the requirements that need to be prioritized, which subparts of the regulation needs to be considered, maybe only some articles for the different regulations, and you need to do analysis. And so, as you can imagine, it's even more complicated when you do cross-regulatory compliance with multiple regulations. So what we are proposing for this direction is a GCFX that is exactly a framework that can support for the cross-regulatory compliance. In any case, in our vision, what we are doing is to try to deal, first of all, with single regulations, so single frameworks that can support for the compliance for the single regulation. And then we will start soon more in detail the process also on analyzing the cross-regulatory compliance aspects, then to create an overall framework that can support for the compliance with multiple regulations. So I will skip some slides because there are many details. So in any case, I will give you the most important concepts. We are designing our framework based on meta models that can capture important concepts of our regulatory landscape. And I will use this slide that summarize the meta models that we use and the method that we are proposing. So what happens when we use our framework is that, for example, considering, let's say, the AUA Act, so a single regulation to simplify the example, in practice we have an high-risk scenario, so we need to create an high-risk AI system. So human experts, a team of experts need to analyze and to make sure that the solution is compliant with AI Act. And this team of experts can be made of multidisciplinary experts. For example, we can have software engineers, project managers, lawyers that interact. And what happens is that they start using our framework that will propose the context model in a visual way. That is a goal model. Sorry, it is a context model. And in practice, this model will show what are the most important factors to consider when we are starting analyzing the compliance of your AI system with the AI Act in this case. So you need to consider which are the stakeholders involved, which roles they will cover, what are the data processing activities that are involved, if the system is high risk or low risk, or how can be categorized, because then you have different articles to consider, what data types are involved, what are the risk levels. So you do this initial analysis that is very strategic, because based on that, then you will reason, the framework will reason over the other models that can suggest how to apply the compliance. So after doing that, instantiating this model, then the team of experts in practice is shown another model that is related to compliance, and also in this case is a goal model. So these encapsulate the most important principles that you need to consider and that can be related to the selection of contextual elements you have individuated. So this can be, for example, robustness, fairness, accountability, fairness, and all the principles that can be considered. So here the team of experts can consider to keep all of the principles, or maybe need to comply for that task only with one principle or more, and so can also make a selection. So you can do an overall compliance or also a compliance targeted towards some principles. So let's assume that we keep all the principles, then we go to the regulatory models. So in these are, we have one model per regulation, and the framework will understand which regulation apply to your particular scenario. In this case, we have simplified with only A Act, and in any case, the framework, so based on the context individuated and the principle selected, will identify what are the articles that you need to consider in relation to complying with AI Act. So here there is also an analysis from the human, decision, interpretation, etc. So we have always the human in the loop. And then we move towards the solutions model. So based on the articles and the related elements that we kept in this phase, then the framework can propose some solutions to apply for fulfilling the articles, the requirements that we identified. And so in practice, the system can propose the usage of tools, method, and other similar solutions for fulfilling such aspects. So this was just to give you an idea about what meta models and the method that is included in the solution we are proposing. And we have started also evaluating it. So we evaluated it in a controlled experiment with 70 participants. And in this case, we proposed to the participants two scenarios of high-risk systems. The first one was related to an AI system that managed pancreatic histologic diagnosis, that in practice is related to analyzing images for these particular health issues. And the second scenario was related to smart porting biometric gate. That is in practice what you can find in airports. So when you do your control security checks, you need to use your passport to have facial recognition, etc. Of course, also that one can be categorized as an high-risk system. So what we did was to divide the 70 participants in two groups and in two rounds. In the first round we had one scenario, in the second one the second scenario, and in each round each group used to analyze the compliance in relation to the scenario proposed. One group used our tool and the other group did a more traditional compliance analysis. And then we, again, for rigorous aspects of the evaluation, we swapped the two groups and we proposed another scenario to reduce potential biases. So we positively addressed the research question we considered, and what we learned was that our approach can support and guide in relation to the compliance analysis. And we understood also comparing let's say the manual analysis with the guided one with our prototype, that in practice our approach improved also the accuracy of the resulting compliance decisions and reduce also the manual effort involved. So we had promising results in a realistic scenario, but in the future we will try it in real scenarios. And we have had also good feedback from the participants and towards the fact that our approach could be useful also for other regulations. So in this case, we covered the AI Act, but in the future, it could be used also for cross-regulatory compliance and for other regulations. And another good feedback was also that the participants indicated that can be useful our approach also for other domains, for example, for fintech and financial services to map technical system characteristics to legal obligations, or to more technical situations where for IT to analyze compliance of software specification to relevant legal provisions. So this is also interesting for future works. In addition to that, of course, as I mentioned, what we will do, we will to continue going towards the compliance with single regulations and then to the cross-regulatory compliance and to evaluate it in a real case study. So this is just to summarize what I have just said. So we have so far covered the AI Act, we will cover the other regulation and then the cross-regulatory compliance in relation to all the regulations. So I was checking the time. Okay, so we have still time. Good. And so now we go to the, let's say, the core part of this keynote, because of course what we have covered so far was very specific in relation to very crucial and important aspects in how to integrate AI within software engineering activities for security purposes and compliance purposes. In any case, what we really need is to design a complete approach, a complete backbone for evolving our software development lifecycle towards creating a secure system, but that are also trustworthy systems. So as I mentioned, that can fulfill also the new principles related to robustness, fairness, reducing biases, and the other aspects that are introduced by the new area of AI. So this work is the result of, and it is an ongoing process, it is the result of collaboration with both academia and industry. So we have universities, for example, the Università Vita Salute San Raffaele, it is a healthcare university where we also evaluated our model that we are proposing in this part of the keynote. And we also collaborate with a multinational company that is called Deda Group, and also with another company called Synapsed. And just to, we already covered these aspects. I will just summarize again for you. So of course we need the evolution of this software development lifecycle because we have new complex multidimensional aspects to consider that are related to compliance, regulatory aspects, but also related to security by design, privacy by design, ethical aspects, etc. And on the other hand, on the technological part, of course, everything is going very fast with the introduction of agentic infrastructure and also of many other technologies that are complicating, of course, these aspects. So, as I mentioned, what we need is an overall approach that can cover the evolution of these practices for considering all of these aspects and supporting software engineers and organizations in relation to these complex activities. So just to mention quickly that there have been, of course, previous evolutions of the SDLC. So, of course, the first one has been the traditional software development life cycle with its traditional phases. And then there have been an evolution with secure SDLC, where on top of these phases have been proposed specific processes, activities, and related best practices that need to be done in order to make secure a software system. So what we are proposing is to doing a further evolution of the secure SDLC towards AI trustworthy SDLC. So again, keeping all the well-established consolidated practices that we have proposed so far, but trying to introduce new concepts, activities, and processes and roles related to of course, the creation of AI-based and trustworthy systems. So what we propose is AITSTLC. This is an approach for the software development lifecycle of trustworthy AI systems. And just to give you an idea in how we designed it, so what we did has been to, in practice, consider a lot of relevant sources that range from regulations such as the EU Act and other regulations, frameworks that are not only related to Europe, also related to other parts of the world. So, for example, we have NIST, that is an American framework related to risk management. Standards like ISO and also ETSI. This is not updated, sorry, so we are considering more sources, also ETSI, for example, and communities like OWASP, that, as you know, it's a very important one, that, of course, for example, provides some tools and also some methodologies for testing AI, for example, or for evaluating the maturity of AI systems and the potential risks related to that. So, thanks to this analysis, we derived the principles that we need to consider in this new model. What are the threats, the new threats introduced by AI solutions, and also to identify countermeasures, potential prevention activities, and other solutions. And we identified also the new AI roles that need to perform all of these activities. So doing this, all of this analysis and many mappings, we have been able to design this new model called AITSTLC, and this slide is exactly what I mentioned. So we did a lot of mappings of these concepts for introducing them within the more traditional phases, let's say. And then what we did was to evaluate it in a case study. In this case was in healthcare settings, collaborating in particular with the Università San Raffaele in Milan, in Italy. And in practice, what they needed to create in a project was the IAB risk management framework. That is, in practice, a framework for monitoring the current AI solution that they are using in a hospital in Milan for the healthcare activities. So to monitor these AI systems and to dynamically evaluate the risks related to that and to apply countermeasures in case, for example, there are biases that comes up or other important issues related to that systems. So in order to design and implement this complex framework, they used AITSTLC. And so we had different phases, so I will skip some details because there is not enough time. So in these phases, they had to cover, for example, to consider a governance, as I mentioned before, to align operationally what they had in place with also what was required in terms of evaluating trustworthy principles and carrying on different procedures by using our model. And the most important and critical part was to guarantee to apply the solution with operational continuity of the current practices, healthcare practices that they had while introducing the new system, and so to making sure that everything could continue working safely while in this system that, as you can imagine, it is. So just to summarize our results, applying AITSTLC, so we had been able to cover, to apply most of the principles and practices proposed by it. So we covered 85% of AITSTLC. We were not able to cover some of the procedures because of some constraints of the projects and other aspects. In any case, we evaluated most of AITAM-CSE with the positive feedback by the participants that used it within the project. And so in practice, it has been applied to a real world scenario with interesting results. So of course, what we are doing is continue working on that. We are currently testing AITAM-CSE to another healthcare project, but for a more complex system. And in the future, we will also evaluate it in additional settings, and potentially it is better, of course, to test them in heterogeneous ones, not only healthcare, even though it is a very important domain, but also maybe in finance, in banking, in municipality, or something related to that. And the future work idea is to operationalize it. What does it mean? It means that what we are proposing is a strong theoretical model that can be applied with good results, as we have seen. But in the future, we would like to, based on that, to create an operating framework, so something that can guide practically in applying the theoretical model in real settings and in semi-automatic ways, always keeping the human in the loop. And this operating framework could be maybe in any case created on top of an agentic infrastructure that can help in all of that. So I check the time. Okay, I will go quick. So there could be space for some questions. So in the last part, so everything that we have done so far, we have introduced so far, it's very interesting and useful, of course. In any case, what we are not discussing is the post-quantum transition. That is another pressing issue with a lot of advantages, but also potential issues if organizations are not ready for the post-quantum transition. And our approach has been to use a CBOM-based approach. And of course, sorry, as I mentioned before, happens is that we are creating the towards the post-quantum transition, but in any case, we need also to evolve and to consider also these aspects in relation to it. So we are using for the post-quantum transition a CBOM-based approach. What is a BOM? BOM is bill of material. So bill of material is increasing mentioned and required by regulations, in particular EU regulations. In practice, is creating a bill of material, so a representation of the system in relation to certain aspects, for then operating a precise analysis over it. For example, for vulnerability identification on a system. And C stands for cryptographic. So in this case, the CBOM is a bill of material for representing all the cryptographic aspects of a system. But we have also SBOM, that is software bill of materials, so related to all the architecture aspects, functionalities, libraries, and supply chain of a software system. We have also the AI BOM related to the classification, categorization of AI models and their aspects. And so the idea is to use this representation then to perform analysis, as I mentioned. So for the post-quantum transition, we are using this approach based on CBOM. What we did has been to start with a pre-existing tool from IBM that is called CBOM Kit, that can analyze the source code of a system and in practice generate as a JSON a CBOM. And then what we did on top of that, we extended the tool for performing CBOM analysis and passing some security policies for checking important aspects for regulations and for guidelines. And in practice, these produce a complete risk assessment in a visual way with also a report, etc., that can help organization identifying potential cryptographic issues that need to be fixed towards the post-quantum transition. So this is what we are doing so far, but there is a lot of feature work to do. So we started recently, and in practice we need to extend more because the current approach and tool support a few languages, so we need to extend it to more programming languages, and also the same for more cryptographic libraries. And now we are also, because this is based on more traditional approaches, we are now also trying to introduce LLMs in trying to automatize most of these aspects, also in the generation of the CBOM, but also in the management of the policies and in performing the risk analysis, risk assessment. And in the end, we would like, of course, to have also from the risk assessment also to apply automatically code correction, for example, to cryptographic libraries in order to make the system ready for post-quantum transition. And of course, we are comparing also the advantages and disadvantages in using more traditional approaches with the introduction of LLMs for these processes. So I have many slides here. I will not enter into details. I am using only these slides, also because we are collaborating with another research unit that is more expert than us in relation to cryptographic aspects, and we are collaborating with them. In any case, I wanted to give you also a flavor about this important topic. So I will go directly to the conclusions. Just to summarize very quickly, what we have done is to consider the new multidimensional aspects, the new challenges that we need to consider, our organization needs to consider in this new era where we are integrating AI, LLMs within our software engineering processes, activities, and the final end will be to create a complete evolution of the software development lifecycle that can consider both secure and trustworthy aspects, as we discussed before, as well as, of course, guaranteeing or supporting towards a continuous cross-regulatory compliance. And in all of that, we need also to consider the other pressing an important issue that is related to the post-quantum transition. So I leave just this slide in case there are questions that can help. Also these slides with more details in case this can help. And just thank you very much to all of you for attending my presentation. Again, it's been a pleasure for me to give this keynote. And if you have any question, I will be more than happy to answer. Thank you.
Dr. Luca, for your valuable keynote. And we have learned a lot about trustworthy AI, the AI SDLC, how we can transform SDLC to trustworthy AI SDLC. And also we learned about how compliance meta models can provide effective guidance for regulatory analysis by improving accuracy while reducing manual effort and promising results in realistic scenarios, potential applicability across regulations and professional domains, and a lot more. In trustworthy AI SDLC, how we can understand the case studies and what are the risks involved in it, what are the threats involved in it, and a lot more. Thank you for your valuable keynote. And I would like to request if any faculty or student have anything to ask to our speaker, they can go with that. Do you have any questions for sir? Well, he spoke about trustworthy AI SDLC, conversion of SDLC to trustworthy AI SDLC, some security aspects, okay, and also some case studies. So if you have any doubts regarding that, you can ask our speaker. Right now, they do not have anything to ask, but if they do, I would like to send your email to them so that they can ask you via email. Is that okay for you, Doctor?
Sure. I would be happy to answer to these questions by mail. That's fine. Thank you.
Thank you. Thank you so much for the wonderful keynote. And we learned a lot about your research, and we will try to apply that for ourselves also in our institution. Thank you so much.
Thank you very much. Have a lovely day. Bye all. Take care.